start, not the first one, because with the first class that was not possible. Then moving forward, I'd like to emphasize the concepts from the previous class. So here's the first question. What type of equation is this? So this is a anyone, please?
Rational.
Excellent. It is irrational because it has... Oh, did I start the video? Yes, I did. Yes, it's a rational equation because it has x in the denominator. Awesome. Very good. Next. 2x minus 1/2 x plus 4 equals 2x is a... Please? I forgot to say please. I'm sorry.
Is it still irrational?
Careful.
Is it linear?
Very good. Because the denominator does not, there is only one, it doesn't matter how many, but the only denominator does not have a variable. If it doesn't have a variable, of course, and if the powers of x are all 1, and so on and so forth. Right, there are other situations. Is this one, x times y equals 4, is this linear? What do you think? Anyone?
Yes.
So this is not a linear equation because we have to solve for y, and when we solve for y we get 4 over x. So this is not linear. So the point I'm making here is, even if both variables have power 1, this is not a linear equation because it's a product of two variables. So a linear equation requires no x in the denominator, all x's, or the variable, the only variable that it can have, all x or any variable, right, have to have, all of them have to have power 1, not negative 1, and there are no products of variables. So this is a rational equation. This product turns into y equals 4 over x if we divide both sides by x, and we get a rational equation. Okay, perfect. This. How do we call this?
Nonlinear?
Well, so let's take a look at what it means. Is 1/2 the same thing with 2/4?
Yeah.
Good. How do we call this?
Is that like an identity?
That is an identity, correct? But there was something we discussed and we reviewed a minute ago. What is it? I'm going to change it. A over B equals C over D. Because you're right, it was an identity, but I was referring to something else. I changed it. So let's say A over B equals C over D. What is this?
Proportion.
Thank you. Proportion. Awesome. Only in a we can, I'm missing two words. Only in a we can ... multiply. I'll put in the first word. We can Very good. Excellent. binomial squared turns out to be always a what?
Positive number.
Correct. But when we square a binomial, we always get?
Difference of 2 squares.
No. This is a difference of 2 squares. We're going to get there in a minute. So binomial squared is always a. Anyone?
A trinomial.
Yes. Please remember, a binomial squared will always have 3 terms. Always. So this has to go. Always. Good. 5 over 0.
It's undefined.
Thank you. X plus 2 over x minus 3 is dot 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 when x equals 3.
It's undefined again.
Of course. Perfect. This, which we already discussed, is equivalent to, and you have 2 different options here. So this is equivalent to, and what are the options? We looked at both options last time. What is the first option?
Cross multiplying.
Correct. Very good. AD equals BC. What is the other option? Another way of writing this. We did that last time. B over A equals D over C. Same thing. Only in a proportion. We can cross multiply, and also if we flip the left hand side and we flip the right hand side, we still get the same thing. BC equals AD. Finally, how do we factor the difference of squares? This is the difference of squares. We used it last time in one of the problems. Can anyone give us the answer for that? Anyone, please? Anyone? I know everyone knows this because this is basic algebra. There is no discussion.
A plus B times A minus B.
Thank you very much. Excellent. That's it. That's the difference of squares. And of course I can have this and come up with the difference of squares, and I can have this and factor it. So I can multiply and get this, or I can factor and get this. So please remember that, it's very important. Good. So we are still the first handout, and we did talk about linear, rational. Now we are looking at a third type. I'm going to write the title in a minute because I would like you to come up with it. Okay, so here's the equation is number 55 on our handout. 3 plus the square root of 3x plus 1 equals x. How do we call something like this? What is it? We have to be able to identify it. If we identify it correctly, we have great chances to solve it correctly. What do you think this equation is all about?
Radical.
Absolutely. How do I know? By simply reading it or looking at it, right? 3 plus the square root, so it's radical, equals x. Radical equations can have 1, 2, 3 radicals. We're going to look at simple ones. I didn't see yet equations with 2 radicals, but we can talk about them, of course. Now, if the equation has only 1 radical, anyone remembers what we need to do? If it has 1 radical, like this one.
We would have to subtract 3 and then
Of
square
course,
both sides.
isolate, very good, the radical. That is the key, isolate the radical. Perfect. So I'm going to move 3 to the other side, and I have the square root of 3x plus 1 equals x equals positive, moves to the other side, it changes its sign. Perfect. Awesome. What is the next step? Anyone? It's okay if you're wrong.
Square both sides.
Of course. Why don't I cube? I want to cube both sides. Why wouldn't you let me cube both sides? I want to cube.
It's just a square root.
Of course. Absolutely. But what if I had the cube root here? What would you have done to both sides?
You'd cube.
Of course. What if I had the 4th root? And so on and so forth. Good. Let's square the left hand side and let's square the right hand side. Can anyone give us the left hand side?
Three x plus 1.
Very good. Nice and easy. Can anyone square the right hand side?
X squared minus 9. Oh, actually, you're so right.
X squared
To
minus
be,
3x minus
to be
9.
honest, you really helped me because making mistakes we learn. So I was hoping that somebody would say that. So thank you. Yes, so what was it?
X squared minus 3x minus 9.
So let's put the formula in. Let me put it here. A plus b, everything squared, is a squared plus twice ab plus b squared. If we have minus, it's the same thing. It's just a sign change on the second term. So, minus 2 times the first times the second plus the second term squared. How do I write this?
X squared minus 6x plus 9.
Excellent. Good. So here we are. What type of equation is this now? It was radical initially. But what type of equation is this? Because we have to decide what to do. If we don't identify it correctly, we don't know what to do.
It's quadratic.
Exactly. Awesome. So now this is quadratic. Now we have to dig deep. How do we solve a quadratic equation? What do I need to do?
the quadratic formula?
First step. First steps first. What is the first step? Mandatory step. What is it?
Set it equal to 0.
Yes, that is the mandatory step. And in that process, I'm also going to arrange it in descending order. That's extremely important. X squared minus 6x minus 3x, 9 minus 1. One more time. It doesn't matter how you write it. It's the same thing. A equals B, B equals A. Same thing. So I kept x squared. I kept negative 6x and I brought the 3x to the other side, making it negative 9x. I kept the 9 and I brought the negative 1. 9 minus 1 is 8. Good. So now, although we haven't reviewed factoring, we should be able to factor this quickly. We will review the quadratic formula as well, but it's too easy. Let's identify the factors. Can anyone give us the factors?
X minus 8, x minus 1.
Very good. So then we have x equals and x equals. Anyone?
X equals 1 and x equals 8.
Very good. This radical equation, by comparison to the other two, we never had to worry about it, about solving a linear, and if the solution worked or not, because there are no restrictions. So, assuming I did not make a wrong step here or there, we should always get the correct solution. Here, we have to state restrictions. It's a must. We have to state restrictions and we have to check against the restrictions. Like the previous example, it was the 6 or negative 6. It was not among the list of restrictions. It was okay. Here we encounter a different issue. The problem with radical equations, here we state restrictions and recheck. Here, we must check no matter what. Must check. Of course, back in the original problem. So we cannot conclude that these are the solutions before I go back and check in the original problem. That is mandatory. So I will copy the original problem, which was 3 plus the square root of 3x plus 1 equals x. It is possible that one works and the other one doesn't. Or this one works and this one doesn't. It is possible that none of them work. It's possible that both of them work. I don't know. It's a must. It's part of the problem, part of the solution to the problem, to check back in the original problem. Okay, so I'm checking 1. I know that 1 is not going to work. It's not possible. 3 plus a positive number cannot be 1. This is called extraneous. Extraneous solution. It doesn't work. It's okay here. It works here. It works here with the 1 with a square. But it does not work in the original problem, so we don't care for it. It's out. At this point, I have to check 8. I'm checking 8. 3 times 8, 24. Plus 1, 25. The square root of 25, 5. Plus 5 plus 3, 8. Yes. And this turns out to be the only solution. And it checks it. It works in the original problem. So again, 3 different types of equations, 3 different concepts. Easy, restrictions, and I have to check against restrictions. A lot of steps, and I must check whatever I get. All the prospect solutions back in the original problem. Only then I can draw a conclusion. Yes, no, yes, no. Okay, so let's hear any questions about this. Hold on one second, I have to